Good morning and welcome to all attendees to this webinar today on the subject of renewable energy, battery energy storage, and microgrid solutions for the mining industry in Southern Africa. My name is Chris Yelland, and I'm the Managing Director at EE Business Intelligence, and I will be your host at this webinar, signed in from Johannesburg. Welcome also to our presenters who will be introduced to you in due course. And welcome to you, the attendees, for your interest and participation. This webinar is hosted by EE Business Intelligence, and I'm going to share a link with you now on the Zoom chat facility where you can download the presenter biographies, which have been shared before, but for the record and for the purposes of this webinar, you can download them now. If you look in the Zoom chat facility and in the Q&A facility, or sorry, the chat facility, you will find this link to enable you to download the presenter biographies. I would also like to acknowledge and thank the Minerals Council South Africa, Solar Group, Sibanye Stillwater, Cresco, SMA Altenso, and the Power Futures Lab at the University of Cape Town's Graduate School of Business for their valued support for this webinar and for the great work that they do in this field. Over 1,700 delegates have registered to attend this webinar to hear what the presenters have to say on the subject. And this attests to both the relevance of the subject matter being covered, as well as to the stature of the presenters. We've got a great lineup today. So may I thank the presenters up front for their participation and for the time and effort that they put in. Please do note that this webinar is being recorded, and links to view the webinar on demand and to download all the presentations will be made available tomorrow morning at about 9 o'clock by email to all those who registered to attend, as well as publicly. The program for the day has been widely circulated already. But again, a link to download the program will be shared again now on the Zoom chat facility. So take a look at the Zoom chat facility and you can download the program for today. After the opening address, we're going to have 4 expert presenters and then a closing address to wrap up with some key insights and takeaways from today's webinar. After this, we've set aside about 30 minutes for our presenters to answer just some of your questions in an open discussion and Q&A session. While the presentations are in progress, please do send us, as participants in this webinar, please send us your questions on the Zoom Q&A text facility, not on the chat facility. The Q&A facility is specifically designed for your questions and answers from the panelists. You may also put up your hands to ask questions verbally, and if there's enough time towards the end of the Q&A session, we'll take a number of verbal questions from people who have put up their hands asking to ask a question. Colleagues, I would normally say a few words at this point to contextualize the background in respect to the renewable energy and battery energy storage in the mining industry and the rationale for this webinar. However, we are really honored to have with us today Mr. Christian Teffo of the Minerals Council of South Africa, who will do this honors and provide an opening address. And I'm sure he'll be covering all of this. And as a leader, as a key leader in this mining sector, I'm sure you would rather hear directly from Christian on these matters rather than myself. So without further ado now, I'm going to introduce Christian Teffo to you. Christian is the Deputy Head of Techno-Economics at the Minerals Council of South Africa, where he has worked for 17 years. He's also had over 11 years of operational experience in the chrome, gold, and diamond mining sectors, most recently as a mining manager. He holds a degree and graduate diploma in mining engineering and an MBA and a mine manager's certificate of competency. Christian works closely with government, industry, and other stakeholders on mining-related policy, legislation, and economic issues. He serves on several boards and councils, including Coaltech, Mines Rescue, and Road Transport Management System. He has also contributed to the Presidency's Electricity Task Team, supporting efforts to accelerate renewable energy projects. So we're very pleased to have you to give this opening address, Christian, and I'd like to now hand over to you to give us your address. Over to you now.
It's Christian from the Minerals Council. So to introduce my company, we have about 66 members. We represent about 90% of production of minerals in the country. And we've been doing this for over 135 years. In the past year, 2025, we produced minerals of about 1.1 trillion. Those are the sales that were realized. This figure will be updated, but it wouldn't change that much. The biggest producers are platinum, which is number one at 27%. You've got coal at 26%, which is basically for energy. And you can just see the amount that we producing that's significant. We then have iron ore at 16.4%. So those are the three biggest producers. And then we have gold at 10%, which used to be number one when I got to the Minerals Council. The industry employs about 470,000 people and contributes about 5.8% to the GDP of the country. In terms of taxes, out of the 1.1 trillion, we're paying about 100 billion in taxes if you put in the pay as you earn up to the royalties. Employee earnings is about 200 billion. Most of these figures have gone up, although some have gone down. Now, mining and smelter electricity consumption, we consume mining alone as operations, we consume about 15% of the electricity from Eskom. Then your smelters consume about another 15%. So in total, we consume about 30% of the electricity in the country. There has been challenges in terms of rising tariffs that have basically reduced our global competitiveness. This has resulted in some of our lower producing or lower profitable mines closing down. And also some of our smelters, currently we sit with about 50% of smelters that have closed down. And so this shows that energy security is really a big issue for us. We produce, Eskom produces about 80% of their electricity from coal, but now with the decarbonisation imperative, we have had to change the way we do things. This is because of the Paris Agreement. Different corporates in the country are looking at net zero targets between the years of 2030 to 2050. And we do have increased pressure from investors and customers in terms of this. And this is shown with regards to banks no longer giving finance to coal mines as easily as they would because of this. And you also have things like the CBAM, which regulates where you buy your material. So if a country is using fossil fuels, other countries will reduce their reliance in terms of procuring minerals from you. But then the other thing is this transition must be affordable and equitable. And so I wanted to use this slide before we talk about the cost. So cost of electricity is quite high. And because of this, as the Minerals Council, we started engaging with the ministers and the presidency in terms of making sure that we deregulate generation build. And also this has also gone into distribution and transmission successfully. Now this has resulted in about 18,000 megawatts being registered of electricity and mostly renewable being registered with the NERSA at a cost of currently about 17 million per megawatt. That would generate or put in capital into the economy of about 300 billion. The interesting part of this is that now these projects are no longer concentrated in the Cape regions, but are now spanning all over the 9 provinces due to the challenges that we have on the grid. So mining remains a key driver of this new capacity, as I would say about 60 to 70% of that would be coming out from mining. We've recently got an update from Operation Vulindlela, which sits within the presidency and deals with different challenges, including electricity, water, and security in the country. And they have, through NECOM and other structures that they formed, made sure that we have key enablers, like the market operator license issued to the NTCSA, the grid capacity allocation rules, and all those other rules. Some of them, like the electricity trading rules, are still out there for comment. So the enablers has been set by government, showing that government actually wants to assist us in terms of coming to a workable solution and getting to a point where our smelters don't need to move to other countries like Asia. In terms of private generation pipeline, the presidency has got a different figure, which is 24,000 megawatts. But you should remember that some of these capacities still in the feasibility stage and wouldn't have been registered by the NERSA. The government procurement process has got about 4,000 megawatts that should be coming online soon from the different determinations. And that would bring in about 16 billion in terms of new investment. What does this mean for mining? It means greater competition for us. If you look at where we're sitting in terms of the globe, South Africa has got big cost in terms of getting our products from here up to, let's say, China. And so that would entail either road, rail, then it should be seaborne. And when you compare us to other countries like Australia, we've got additional cost that we have to pay before our product reaches the customer. And so that's why we need to make sure that we are very competitive in terms of pricing and how we do things in the country. Due to the other enablers, we have now got transparent and fair grid access. We've accelerated private investments, improved energy security, and also have set foundations for wheeling and trading markets, although there's still a question about municipalities being able to handle wheeling. I think I've talked to the grid constraints. We've seen RFPs come out from the DE in terms of assistance from private entities in terms of building the grid in South Africa. And so these are all things that will help us to be able to wheel our energy from wherever we set up. We've also got the TDP, which urgently needs to be put in place or implemented to ensure that we've got the grid in place. In terms of battery energy storage, I mean, we have seen a lot of companies in South Africa doing research in terms of batteries. We've seen Eskom implementing some battery storage at their research site in Johannesburg to try and test out how this can work for us. The price is still high, but as in renewable energy, the price was high. If you look at bid window number 1, the prices that were achieved there and the tariffs that are currently going out for bid window 7. And so the belief is that battery prices will also fall as we've got more production of these batteries and we reach economies of scale. So these are good. An example of this would be some of the companies that we've dealt with within the Minerals Council, where you've got a notified maximum demand. And so you will have renewable energy during the day, let's say covering 30% of your electricity demand. But then in the evening, you have to go back to 100% in terms of what you take from Eskom. Now, it is a challenge for Eskom because what do they do with the supply that they have during the day? And so when you have battery, you can then put in renewable to make sure that you can take the 30% during the day and also be able to supply yourself with that 30% from best batteries. And we see this as a solution. So basically, you would need to have integrated energy solutions, even going to hybrid microgrids, which would be depending on solar, wind, and the battery storage. This also, brings about wheeling and trading opportunities. If that electricity is more than you need, you can then wheel it. And as I said, we've got enablers that enable this to happen in terms of the rules that have been set. This also helps in terms of demand management within the national grid. We have seen also in terms of our communities around the mines, where community microgrids also help, with people that live around our mines, to make sure that they are not left out. They also have electricity. So instead of installing transmission lines that span hundreds of kilometers, you can have these microgrids that are supplied from nearby. And this also helps with our local economic development. Practical way forward. This is my last slide. Chris said I see I'm on time. So I think, as we've seen, it is best to collaborate. So we have collaborated with government. We do collaborate with IPPs, OEMs as the Minerals Council to make sure that solutions that would better place our mining industry that is needed for the economic growth of our country is enabled. So what we need is faster regulatory approvals. We see movement in terms of this. We are in talks with the DE, and when necessary, also with the DMPR, which used to be the DMRE. There is investment in transmission grid, as I talked about it, that private companies are also allowed to build and make some money from this. But this also ensures that the SOE or government doesn't have to put in its much needed money into all this infrastructure, and we can share in the risk. Balanced tariffs for competitiveness, we cannot say this more than enough, because if you look at our smelters, there's a chance that they can go to a price. We've seen the NERSA document that says 87 cents per kilowatt hours for smelters. And then eventually they are looking for survival, something around 62, 63 cents. Now, with renewable, with BESS, this can be achieved. And then we don't have to have bailouts or sort of capital borrowed by the government to make sure that our smelters can still go on. So this can be financed by such projects. And with that, I would like to say mining can lead South Africa's energy transition. We are big, we have the experience and the capital to be able to do this.
Thank you, Christian, for those introductory remarks in your opening address, and explaining to us what the mining industry in South Africa is all about, what it contributes, and the work that it's doing, across this whole renewable energy value chain, including wind and solar and wheeled energy and battery energy storage. So I think that was a great opening to this webinar, and I'd like to thank you for your participation. And we're now going to move on to our next main presenter, and I would like to introduce you to Jonathan Skeen from the Solar Group. Now, Jonathan has had 16 years of experience in clean energy projects, in energy policy, engineering, and management, and he's played a key role in delivering private wheeling capacity, including all three of the currently operating utility-scale wheeling projects in South Africa. As the Managing Director of Commercial, he chairs the Executive and Risk Committees and is responsible for business development, marketing, and corporate finance functions. Before joining Solar, Jonathan worked at several large-scale industrial projects in the USA, Italy, and South Africa, and is a clean energy policy consultant under the UN Environmental Programme. Jonathan qualified as a mechanical engineer at the University of Cape Town, and he holds a Master of Science with distinction in technology policy and management from Edinburgh University. So it's a great pleasure to see you here again, Jonathan, on one of our webinars. And I'd like to hand over to you if you can switch on your microphone and give your presentation.
Great. Thanks, Chris, and good afternoon to everybody. I think thanks for having us on another great EE webinar. And we're very excited, I think, as Solar to be talking about battery energy storage, which is for us, it's really just something we've dedicated a lot of time and thought and resources to over the last several years. I'm going to be talking to quite a specific angle on battery storage in relation to the mining sector. There's, batteries can be used in a myriad of different ways, and they can provide a lot of different services. We're going to be focusing in this presentation on an area where we put a lot of work, which is effectively co-locating batteries with wheeling generators to increase the value and the flexibility of that wheeled energy. So just in terms of really the flow, I'm gonna really start quite broad and sort of almost look at the journey that we've been on and that many of our other stakeholders in the industry have been on for the last 6 years around the wheeling of energy, and a lot of that has been to mining off-takers, and also how the supply and demand balance has evolved during that period to a point where the integration of batteries is now really is an essential component of what we do and what we see a lot of other energy companies will start to do, and what mining companies will certainly start to do, obviously behind the meter and in other ways. I'll sort of touch on the topic of improving flexibility of the system generally on the back of high volumes of internet and solar and wind that we're starting to see on the network, and then very specifically look at using batteries to make wheeling flexible. And I've got one or two sort of figures to try and demonstrate how we are implementing this at the moment. And then we'll wrap up with some key takeaways. So just to talk, many of you will be familiar with the Solar Group, but many of you maybe won't be. We are a vertically integrated clean energy company, meaning that we cover really the whole value chain. We develop projects, we finance and own them. We have a construction and engineering company that builds those, and then we operate them during their lifetime, their life cycle as well. We've built or have in construction more than 1 gigawatt of generation capacity, and we've funded about 20 billion rand of assets to date. To talk to come to this timeline. So I mean, this is a journey that we've been on. Our company's probably almost 20 years old, but certainly over the last 6 or 7 years, we've been on a wild and entertaining ride in relation to the delivery of energy across the network to private energy users. So this goes back to 2020 when the first solar wheeling project reached financial close, and there have been a number of regulatory events that have happened that have opened up the wheeling markets as the years have progressed. Some of the key ones have been the lifting of the generation license cap, so where it was very difficult to get the approvals for generators larger than 1 megawatt. In the past, that cap was ultimately removed in 2021. That saw the first large private generators selling to private end users, firstly solar in 2021 at 100 megawatt scale, and wind projects shortly thereafter in around 2023 reaching financial close. We've seen amendments to the ERA Act, which have also further opened up the market, and some of those changes have been 25 years in the making, but the real progress that has really happened in the last few years with that amendment, the ERA amendment signed into law and then enacted in 2025, has also come in parallel to the first aggregation projects. So the first projects selling from one generator to many buyers in 2023, and moving up to the first projects last year, I think, that closed with a trader as an off-taker. So a full aggregation of both generation and demand, and taking a big mix of different buyers and connecting them up with a mix of different generators. We've now got more than 3 gigawatts of solar and wind capacity, but certainly until now, no energy storage co-located or coupled with that. But 2026, we think, we actually know is the year where we see this now starting to come to fruition. We will see the first integration of BESS. And I suppose as a company, we've got a very big announcement to make in this respect next week. We won't touch on that today, but certainly stay tuned, and we hope to share more details on that early next week. So what's happened alongside that process that I've just looked at in terms of how the wheeling market has evolved is that the volume of variable renewable energy, which we use that term to describe obviously solar power and wind power, energy that is available as the sun shines or the wind blows, has grown dramatically. So we've got more than 15 gigawatts of solar and wind effectively connected to the network, both behind the meter and in front of the meter or at the utility scale. There's actually a huge amount now of rooftop solar, which has a big impact on the supply and demand balance in the network. And so what you start to see is that these generation sources, which are not dispatchable, so they can't be controlled, they generate when they are available, and they don't generate when the sun isn't shining or the wind isn't blowing. They start to have a significant impact on the supply and demand balance, and effectively are hollowing out in daylight hours caused by the large volume of solar that is growing on the network. Now, this is commonly referred to as the duck curve effect, which many of you would have seen some reporting on, and probably quite a nice graph. It's happened in several markets that are a little bit more mature than ours. If you look at the Californian example, you see how this duck curve effect gets more and more pronounced, and the duck can explain how they came up with this strange name. What this basically means is that you really have a decrease in you have this decreasing demand in the day, which obviously has a supply and demand effect on the cost and the demand for that power at those periods. So you start to get a lot of cost compression in the middle of the day, but you're still not servicing these evening peaks and these later sort of evening periods with that clean energy that you are producing, which creates an imbalance in the system and even the potential for grid instability. And what comes out of this in any network system where you're getting more variable wind and solar is a strong demand for flexibility. Now, I talk about flexibility in the system in general, and there are many different ways that you can find, you can sort of procure or sort of embed flexibility in the power system. And there's lots of different ways that you can see that here. We're obviously just focusing on battery energy storage, and batteries are a very powerful tool for adjusting when the power is dispatched, and also providing short-term and frequency response and network balancing services. So we're kind of zeroing in on that. There are lots of other sources as well. These are quite physical sources. This is actually these are sort of things you can touch, and chemical sources, mechanical, electrical, etc. But there are also financial markets. There are the potential wholesale market. There are lots of other ways that you can bring flexibility to the system. Again, we're zeroing in on storage, and we'll start to zero in on the co-location example, which is the specific one that we have been working very hard at. So when we sort of focus in on the battery side in terms of getting flexibility, how can mines start to get the energy when they need it? Not just the lowest cost energy, but and not just clean energy, but to get that clean energy, that low cost energy, actually at the times when it's useful to them. Because you can get as much energy as you like during the day, but maybe your demand profile is quite flat, and you use a lot of energy at night. There are three different ways that mines can use energy, use batteries to achieve that flexibility. You can co-locate it at a wheeling generator. So if you're purchasing energy from a wheeling facility across the network, a battery can be placed at that generator to change the way that generator dispatches into the network for the energy that you are receiving. You can also potentially have a standalone battery without a generator on the network, or you can place a battery at your load point. And each of these different approaches has slightly different nuances and benefits. And we are sort of focusing at the co-location, and really the benefit that we see there is that there's a range of different services that you can get from that. You can use an arbitrage mechanism to store and then dispatch energy at the most valuable times. You can use that battery to maximize by matching the off-taker's demand to maximize their renewable energy coverage. And in future, as the market starts to open, you'll be able to use that battery for other quite lucrative services in terms of balancing the network and providing ancillary services. There are some unique benefits to co-location of BESS. You mitigate the curtailment risk associated with those generators. So if you've got a solar plant that potentially is generating in daytime, and there's a big surplus of solar on the network, you can mitigate that risk. There's potentially network charge benefits that arise from the way that the batteries are used. And the battery can potentially be operated by either the bio or the solar. So now I'm going to talk to two sort of slightly different use cases and just a reminder to think about how we focus in here. So this is a co-located wheeling project, and we've looked at two different use cases here, basically on how we will use that battery to increase value. So in the first case, if you think about an arbitrage model, we take as much solar generated during the daytime, and we soak that down into the battery, and then we dispatch that in the morning and or the evening peak periods, which are the times of day when our clients and our mining clients typically pay the most for their energy. So those are the peak demand periods. There's a big premium on the power in those times. So we want to try and shift as much power as we can as possible to those periods. Now, if this graph is confusing to you, you are not alone. It's quite a strange visualization of Eskom's wheeling mechanism, which is a monthly reconciliation. So this is actually effectively the power generation or the power output of a solar project, a 300 megawatt solar project. The reason it's blocky like this has to do with Eskom, the way that Eskom reconciles over the course of a month. But what I'd probably ask you to just focus on is that the yellow block, that is the energy that's being put out in standard periods. Eskom has standard periods are predominantly in the day, and that is a period that overlaps a lot with the generation of solar power. And that's why you see a lot of power coming out of this system in the standard periods. The red is the peak. So solar doesn't generate at night, and those peak periods are in the evenings, and they're sort of actually starting to move further. In the last tariff adjustment, they started to move further into the evenings. There's not a lot of peak period generation from a solar generator, just for obvious reasons. Now, if we take the same generator and we add a battery to this, a 2-hour battery, you start to see, and we start to shift from the yellow into the red. We start to see a flatter, first of all, the most obvious thing is a flatter generation profile over a longer period on average, but also a substantial increase in the amount of power that we're pushing into peak. And this is where a lot of value comes through in this most basic use case, this sort of simple arbitrage of energy between standard and peak. We've crossed a lot of economic milestones with this model in the last 2 years, but as it stands, if you add a battery to a large-scale solar generator, you typically get about 25% better savings. So the economics are already dramatically better than a solar generator on its own. It's highly predictable because the battery obviously dispatches. It's dispatchable hardware. So especially in the peak periods where we get a lot of the value, you are in control of that facility. It's not just waiting necessarily for the sun to shine or the wind to blow. The blended costs of these systems also have now have actually for some time been very compelling. And obviously in the past, the narrative has strongly been that batteries are still very expensive. Actually, we see now that the blended cost of the solar and the battery configuration is very competitive on an average tariff rate. So below 1 rand a kilowatt hour on average, your equivalent sort of average Eskom tariff that relates to this type of generation profile is more like 1.60, 1.70. So it's a substantial gap. And of course, it's already happening. And as I mentioned, we'll be sharing more details on that soon. So now that's a maximum savings type of profile, putting as much into peak. But what about when buyers want to start to match a flatter demand profile, if they want to have more coverage over the 24 hours, or if they want to have a higher renewable energy penetration? They want to save money, but that's not the only priority. They also want to have a more useful generation profile that covers more hours of the day. Well, this graph basically takes that same facility. We've increased the battery storage capacity from 2 hours to 4 hours. And we've done a simple exercise of capping the generation capacity. So we can put out a maximum of 300 megawatts, but in each case, we use the battery to cap the generation capacity at these different thresholds. And what that does is it starts to squash that generation profile out, and it makes it flatter and cover more hours of the day. Now, this blue shape is actually the maximum savings model that we looked at earlier. So this is targeting the morning peak. All the solar power in the day is being drawn down to charge the battery. And then once that battery is full, we start to discharge that solar again. And then in the evening, when the peak comes, we discharge that battery to get the evening peak. So that's why you get this funny squiggly line for that maximum savings, which is very different to the these sort of more baseload type generation profiles that we're illustrating, where we just start to spread them out as much as we can. So this is effectively during the winter months, but if you actually go to the summer months, you see you get quite a lot more coverage as well. And so from a technical perspective, you can start to get up to 17 hours of effective solar power, 17 hours a day, which is the 4-hour battery. Obviously, the larger that battery becomes, the more you can extend that. And I think what's very interesting about this is actually that all of these cases are actually economically viable, if I can say that. So you're still getting a substantial saving from this green profile, even though you're not necessarily taking maximum advantage of this arbitrage into the peak periods. Each of these cases is as it stands economically viable. You're getting a substantial saving by adopting these solutions. And that as battery costs evolve and as general electricity prices increase, that picture is improving. So just a little summary of that last graph. So we looked at that maximum savings structure. You're getting a capacity factor. Capacity factor is a representation effectively of how much of your rated generation capacity you are using on average over the course of a given year. You're using about 30, you're getting a 35% capacity factor with that maximum savings structure. So it's sort of similar to a wind project, and obviously very strong economics. And then as we flatten that load profile out, that capacity factor obviously increases substantially. We're getting up to sort of 60 to 70% on that lower version. And again, strong economics actually all the way up to this 150 megawatt cap. And actually, we last did this evaluation on the economics of this a couple of months ago. We actually think that that's probably changed and has gotten quite a lot stronger. So that's just a quick snapshot of where we've been. Again, I think we're very excited to announce and for an announcement we'll be making next week. We will share a lot more detail and on a project of ours that is pursuing some of these mechanisms. But just looking ahead, I think that there are probably 3 really interesting and sort of important points around batteries and on the utility scale that we think are going to be very, very exciting. One is the obvious evolution of battery economics. The learning curves and the cost decreases of batteries are continuing to come down sharply, and that's going to increase the range and scope of both hybrid and standalone batteries, and both behind the meter and sort of wheeling batteries, and open up the range of economically viable solutions that you can leverage with those batteries. The next very exciting point for us is that there are new markets for battery services on the horizon. There is the obvious one is the impending sort of balancing market, where generators on the network will be subject to balancing, making forecasts and honoring those forecasts, and batteries will play a strong role in potentially offering services to balance the network as well as provide other ancillary services. And then critically, the evolution of the network, the actual grid infrastructure, where it's obviously well known that the grid is highly constrained in South Africa. Good quality grid connections for renewable generators are very scarce and hard to secure. So batteries are extremely important for both in terms of existing generators from a retrofit perspective to manage future risk, to reshape those generation profiles moving forward. And then also to maximize the value of those grid connections. If you think about it, a solar or a wind project on its own really only uses about 25 to 40% of the value of that grid connection. But the more we add storage to those generators, the more we can start to really maximize the rated capacity of those generation connections, which are in themselves an extremely valuable resource. So I'll leave it there. I hope that was at least a bit of a snapshot into one of the business cases that we have been spending a lot of time on, and I'll hand it back to Chris. Thank you.
Well, thank you, Jonathan. And interesting this concept for the mining industry, and other customers, I'm sure, of co-locating solar PV and battery storage facilities. And you've got our You got us on the edge of our chairs waiting for your announcement next week. We're not sure what it's all about, but it's something big from what you say.
We're
And
very
so we're
excited
going
to
to be
announce it.
watching this space carefully to hear what is coming from the solar group in the next week or so. Good luck with that. Yeah, we're watching with interest. So thank you
Thank you.
very much indeed, Jonathan, for that presentation. And we're now going to move on to our next speaker, who is Dr. Muzi Dlamini from Sibanye-Stillwater. And Muzi is the Vice President of Energy and Decarbonisation at Sibanye-Stillwater, where he leads the group's global energy and decarbonisation strategy and oversees one of the largest private renewable energy portfolios in South Africa. With 19 years' experience across the energy and power system sector, his expertise spans energy and carbon management, large-scale industrial decarbonisation, and renewable energy project development and procurement. Dr. Dlamini chairs the BUSA Energy Subcommittee and is a former chair of the Energy Intensive User Group. He holds a PhD in electrical engineering. He's an EXA registered professional engineer. He's a certified energy manager, and he's a certified director with the Institute of Directors in South Africa. So it's really fantastic having you on this webinar, Muzi, and you bring your experience in the mining industry, in decarbonisation and renewable energy, which is exactly what this webinar is all about. So great to have you on board, and we're looking forward to hearing what you have to say. Over to you, if you can please share your presentation.
Thank you, Chris. It's privilege to be able to share the perspective of a mining company, and certainly a journey that we've embarked boldly on, and I'm happy to share some insights from our journey. I thought the big announcement that Jonathan was making was that we've partnered previously on some projects, but I'm also eagerly going to await the next one. Just in terms of what I'd like to share this afternoon is, firstly, I'll talk a bit about who we are as Sibanye-Stillwater. Then I'll look at an overview of the South African energy landscape and how it's influenced our decarbonisation strategy, and then touch into our experience of integrating a portfolio of renewable energy into our South African operations. Firstly, we are a multinational mining and metals processing company. We've got a diversified portfolio of operations, projects, and investments that span 5 continents. We are a foremost global recycler of a suite of metals and a leading mine tailings reprocessing operator. And we've diversified into battery minerals and processing, and a testament to us being invested across the different sections of the mining value chain, including the circular economy. We've got a market cap of 201 billion, and we're one of the largest employers in South Africa with a workforce of about 72,000. Firmly rooted still in South Africa, 75% of the group's revenue is coming from our South African operations. And also tied to that is 90% of our scope 1 and 2 emissions. So from setting the scene, I think my colleague Christian Defo has laid the context quite nicely in terms of the challenges that we're faced in the South African energy landscape. And the evolving energy market has also impacted us. I think the 2 key things that I'd like to touch on, building just on what Christian has said, is we'd all remember the recent security of supply crisis, where we were having quite severe load shedding and load curtailment. And what is still, unfortunately, there's been good work that's gone into the space, and we are seeing significantly improved performance from Eskom. Also, what has impacted ours and informed our approach is energy affordability. As an energy-intensive business, we are very sensitive to affordability. The price is certainly a signal that impacts our profitability with the recent above inflation electricity cost increases really having an impact on our business. This environment has created some significant risks for our South African operations. And from an energy security perspective, we operate deep level underground mines, and security of supply does have not just operational considerations from a profitability perspective, but also serious safety considerations that we've had to look at how to mitigate. With this context and our bold and ambitious sustainability targets, we've responded to this environment, and we've looked at not only what is the negative aspects of it, but we've looked at how we can actually solve for the security of supply, look at how to mitigate affordability as we move towards our sustainability targets. And we've committed to carbon neutrality by 2040, and we've also committed in the shorter term to a 2030 target of a reduction of 42% of our carbon emissions. And in getting to that path, I did touch on that. We said the energy security is paramount. The reduction of emissions is critical, and it also must ensure that our business is sustainable from a cost perspective. And we are aware that we need to partner and also participate in decarbonizing value chains as well as the just energy transition. I think what is a real consideration in terms of how to then looking at options that are available to solve for energy availability as well as energy security. We're faced with options as South African mining companies between considering wheeling projects and behind the meter projects. And various companies have taken either approach and even both. But essentially, it does come to a trade-off between the speed of execution and flexibility that comes with wheeling, and also the long-term cost security and the better energy security that behind the meter projects can provide. So I'll briefly touch on some of the pros and cons of each approach. If we look at wheeling projects, they've enabled fast deployment and improved access to develop projects that are already de-risked, which has been one of the levers that we've pulled. These projects are based on finding the best resources, so they do have that advantage, and that's what actually leads the selection of the locations. They do have the benefit of scaling and the economies of scale associated with that. From a mining company perspective, what it does do is it preserves capital for core mining activities, allowing us to focus our investments in terms of our core business and sustaining and growing in those spaces. From a bankability and contracting options perspective, there are wider options that are available from wheeling, and you also limit the execution risk as a mining company by allowing specialist project developers to take on that risk. There are some downsides. It is more complex compared to a behind-the-meter project. There's a grid interface, there's multiple parties, there's the administration part of it once projects are operational. There is also a constraint that I think we are all aware of at the moment, the grid dependency and the constraint that it imposes, as well as then in trying to navigate that constraint, the curtailment risk that that now exists. There's also charges on top of the direct energy that get built in. So there's wheeling charges that come on, and there's uncertainty about how those will escalate in the future. And being operated by a third party, there's less operational control from the mining company, and the contracting is complex. Multiple parties, from the generator or trader to the utility company to lenders, as well as the off-taker. If we look at the behind-the-meter projects, in this instance, the benefit is improved from the financial return side. You do strip away some of the layers of cost. If you are connected behind the meter, there is no wheeling and the associated costs. Commercial structures are simpler. And it does speak more directly to the security of supply and resilience matter, because it's not impacted by failures on the grid and while transporting your electrons to your operation. And there's full operational control, so you can actually operate it to the best way to fit your operation. And the benefits there are direct to the host community. It does also give optionality to post-mine closure considerations and how to keep economic livelihoods for the host communities in which we operate as an option. There are the downsides. So the upfront capital, you might need to decide to divert capital from core mining activities because it will compete with that. And you are limited by the land and the specific renewable resource that you have within your mine boundary or owned land. And you can have significant exposure to the execution risk to develop the project as well as operating it. And its financial viability has to be linked to the life of mine of the asset that you are connecting it to. What we've done is we're pursuing a hybrid approach. We believe there's a way to exploit both the benefits while mitigating the downside of either of these approaches. Back to our journey. We've taken a diversified portfolio approach to this, where we've looked at developing multiple complementary projects. And this has enabled us to be able to balance agility, risk, and the speed of execution in what is admittedly a very rapidly evolving market as the regulations change and there's more players that enter. When we look at our grid-connected projects via wheeling, we've developed strategic partnerships, and these have allowed us to develop competitive utility-scale projects with credible partners which have executed on time and at scale. And we've taken some early and decisive actions once the regulations became enabling. Castle Wind Farm, which is one of our projects that came online in March this year, reached COD. At the time we concluded that was the largest private wind project in South Africa at the time. Jonathan from Solar Group, is we partnered with them as one of the anchor off-takers for also an innovative approach to the market, where it's the first multi-buyer project, especially at that scale. So we've been decisive, and we've wanted to act when opportunities arise. And what this has enabled us to do is to deliver meaningful strides in developing our portfolio-wide decarbonisation strategy. When we look at behind the meter, we are leveraging access to the land that we have around our mining areas, and particularly strong solar resources. And we self-developing projects at our SA gold and PGM operations, which to the preceding slide speak to energy security, cost certainty, and operational resilience. There's a few design principles that we've also looked at as we've executed our strategy here. We've looked at load matching and resilience. So our portfolio is geographically diversified, and this is to look at reducing single point of grid failure and also maybe regional weather intermittency. Excuse me. And we've balanced technology between wind and solar deliberately to match our consumption profile. And what this has brought us is improved supply stability across different operating regions and time periods. And our portfolio is designed to scale across multiple generation assets and multiple provinces. We've also, as the market has evolved, when we look at the commercial benefits and the commercial side of it to manage risk, we've been aware of the different evolutions of the market and the different phases, and we've acted appropriately to each phase of the market evolution as the regulations and the markets adjusted. So that has given us flexibility to adjust the contract, the technology we've looked at, as well as the commercial structures. So we've secured value accretive projects, which are off balance sheets, multiple contracting frameworks that we've looked at, and we've looked at different contract structures as well, from projects that we build and operate, long-term PPAs and aggregators. We've also looked at the social benefits as a key part of it in how we've developed our projects. I think as I work towards concluding, this is just a picture of what our portfolio looks like. We believe we've developed a leading renewable energy portfolio, and we've unlocked not only the benefit of decarbonizing and lowering emissions, but also enabled this to be a very significant instrument in us lowering our operating costs. So our projects, as you can see in the slide, span across multiple provinces. We've got 2 that have reached commercial operation, and we've got several others that are still in development. There are some insights that I will leave you with in the slide deck, just in terms of the policy and the regulatory environment, and some takeaways that have been part of our journey that I would like to share. And maybe to conclude on a point that Christian opened up on is we're very happy that the regulatory framework has evolved. It certainly has enabled us to develop our projects, and the collaboration and constructive engagements with government, facilitating talks with stakeholders and removing some critical stumbling blocks has been something that has been commendable. So I'd like to conclude on that point. Thank you, Chris.
Thank you, Dr. Muzi Dlamini there. And yeah, really interesting to see the approach of a major mining group with operations not only across South Africa but globally. And interesting for me was this portfolio approach with a diversified strategy. Looking at geographic diversity of having plants geographically dispersed, which overcome some of the potential weather constraints in particular areas. We've seen how you've also looked at hybrid behind the meter. Sometimes behind the meter, sometimes wheeled power, and sometimes combinations of both. And we've looked at your diversification approach, in terms of having different technologies, wind, solar, and hopefully battery as well, and the combinations of these, especially in a geographically diverse environment, seems to offer a lot of benefits, to get the benefits of some of the behind the meter benefits as well as the wheeled benefits. I thought you gave a very insightful look at the issues facing the mining industry and some of the solutions that Sibanye-Stillwater are implementing as a major mining group. So with that, ladies and gentlemen, we are going to call a comfort break of 10 minutes. We're a little over time, I'm afraid, at the moment. It's 3 minutes past 3, and we're going to have a comfort break until 8 minutes past, until 10 minutes. Let's make it until 12 minutes past 3. Gives us a little bit of time to have a break. So can you be back here at 12 minutes past 3? Gives us an opportunity to stretch our legs, maybe grab something to drink, and we'll see you back at 12 minutes past 3. Well, colleagues, it's exactly 12 minutes past 3, and we're going to resume our discussions, and I would like to introduce to you our next presenter, and that is Neil Claessens from Cresco, a company that does advisory work with a large mining customer base. So it's great to have you here with us, Neil. Neil is an associate at Cresco, specializing in project finance, financial modeling, and transaction advisory for energy, infrastructure, and mining projects. His work focuses on supporting sponsors, developers, and financiers through feasibility studies, bankability assessments, and investment decision-making processes. More recently, Neil has focused on the development of battery energy storage models to support renewable energy and hybrid projects, including sizing, dispatch modeling, tariff analysis, and downside scenario assessment, particularly for wheeling and commercial industrial applications. Prior to joining Cresco, Neil spent 9 years in the civil engineering industry, gaining experience across large infrastructure projects. So as I say, great to have you here, Neil, and over to you.
Great. Thanks, Chris. Great to be here and to present some of the work we've been doing at Cresco. So my first few slides will really just give a bit of background on the evolution of the energy market and where BESS fits in. And then I'll share a more practical example of how Cresco are assisting our mining clients to implement battery energy storage, or BESS, into their energy strategies. And just to set the scene and give a bit of background on BESS, the story really starts with change, and not just a single change, but many things changing all at once in the South African electricity market. So over the last few years, we've seen 3 major shifts occurring in parallel. We've seen the move towards a more liberalized market, otherwise known as the South African Wholesale Electricity Market, or SAWEM. We've also seen an increase in renewable energy on the grid. And then we've seen technological and price changes, which is really driving the adoption of BESS. So market liberalization is changing how electricity is bought and sold. We've seen the emergence of traders and aggregators. Wheeling is becoming more mainstream, and the system is moving towards a wholesale market structure. So the market is changing with forecasting, day ahead, hourly pricing, and balance responsibility slowly but surely becoming reality. At the same time, renewable energy penetration in the grid is increasing. And this is changing the mix of energy on the grid. So these electrons are now flowing, but the nuances of renewable energy generation has some real operational implications for how the grid is balanced. And then layered on top of that, we've got technology which is moving quickly, particularly in energy storage. So today, lithium iron phosphate batteries dominate the market, and there has been a significant reduction in capital costs over the last 2 years. And this is materially changing project economics. So further technological advancements in storage will expand the role that storage will play in the grid in the future. But these changes are really all interacting with each other, and technology is then providing the tools to manage all of this complexity. So the need really now is growing for new energy offerings, focusing more on flexibility and balancing and risk management rather than just purely energy supply. So for Cresco clients looking ahead to 2026, this translates into a few clear focus areas. At a macro level, this includes tariff reforms, Eskom retail tariff plan, SAWEM implementation and the progress on that, and how balancing responsibility and forecasting accuracy will be allocated. And from a BESS perspective, it means really understanding value stacking, the role of storage in ancillary services, and how off-peak pricing and grid conditions can be used to optimize charging strategies. So with that context, let's take a look at how these changes are expected to unfold over the next few years. So this is a summary of the regulatory, procurement, grid, and technology changes Cresco expect between now and around 2030. And what's important here is not any single milestone, but really how timelines start to converge. So from a regulatory point of view, we're moving from a bilateral wheeling environment towards day-ahead markets, balancing responsibility, and ultimately SAWEM. And at the same time, private sector renewable procurement continues to scale, but increasingly under constrained grid conditions. So from around 2026, Cresco expects PV plus BESS to become the norm for new private sector projects. And this is largely driven by grid constraints, curtailment risk, tariff exposure, and settlement risk. From a grid point of view, with limited grid capacity and increasing curtailment, BESS becomes a way to unlock value from constrained connections. And this is just by shifting energy in time rather than relying on additional grid capacity. So in essence, BESS can sort of act as a type of virtual grid upgrade. And then as balancing responsibility moves closer to generators and customers, flexibility becomes a commercial requirement, which is really ideally suited for BESS. Looking further out to 2030 and beyond, as renewable penetration continues to increase and coal exits the grid, short duration standalone storage alone won't be sufficient, and that's where long duration storage starts to matter for balancing and system adequacy. And longer duration technologies include hydro, BESS, and gas. And we really need all these technologies in the mix, with each playing their own specific role. But from a BESS perspective, we are really seeing the evolution from short duration BESS, which is solving short-term grid and tariff challenges, to longer duration BESS as the market evolves. So some of you might be aware, but Cresco has done some energy forecasting. And here you can see our energy forecast for September 2024, which was updated in September 2025. We actually do have an updated view on these energy forecasts, and we're using this to do some analysis on marginal system pricing analysis, but this isn't available for the public yet. But based on the Cresco forecast, we will continue to see the decommissioning of our coal fleet, even though EAFs are slightly up recently. We still see imports and peaking plants playing a meaningful role well into the next decade, and this is mostly driven by hydro imports from SAP. We also see a slower rollout of renewable energy projects, mainly due to grid constraint issues. And still of concern to us is that large-scale gas power projects will only come into operation by around 2030. The bid submission date for the government gas IPP program is set for May 2026, but there's still some uncertainty around gas supply and the bankability of those projects. We do, however, see a steady increase in private BESS installations and initially shorter duration BESS, but increasingly the grid will require longer duration BESS to support longer duration BESS support, which is ultimately just necessitated by the delay in gas. But overall, even in an optimistic scenario, South Africa remains a capacity constrained and flexibility constrained system for most of the next decade. And this is really why flexibility assets and not just electrons in the grid are becoming more valuable. So when we look at the hourly energy balancing, we see that BESS is playing a really important role in balancing. And this is mainly due to seasonal changes in demand and generation from the summer to winter months. So the figures show the grid balancing profiles from January and June, so a summer and a winter month, in 2025 and then 2030, and this is excluding any coal. So the first thing to note is a strong seasonality in PV. So the PV output is materially lower in winter, mainly due to shorter daylight hours. But this is exactly when demand is the highest and more sustained. So that seasonal mismatch is one of the underlying reasons why grid stability becomes more challenging as renewable energy penetration increases in the grid. So in the 25 profiles, we start to see short duration BESS coming into the grid to support the evening peak demand. And this is the classic early use case for BESS, absorbing excess solar during the day and then discharging into the evening peak when the demand is highest. And at this stage, BESS is primarily just addressing short, sharp peaks rather than prolonged system stress. But by 2030, Cresco modeling shows materially more BESS in the system. But importantly, BESS is now not just supporting evening peaks, it's also increasingly required in the early morning hours to provide grid stability. So what's changing is not just the size of the peaks, but it's the duration of stress on the grid. And short duration BESS is effective for evening peaks, but as gas availability remains uncertain and the coal continues to decline in the grid, longer duration BESS becomes critical to support both early mornings and extended peak periods. So in other words, BESS starts to move from just peak shaving into system adequacy. So now we get to the more practical part of the presentation and how BESS is being adopted by some of our mining clients. And this is a typical roadmap of how large energy users in South Africa, so typically mining industry or heavy industry energy users, have adapted their energy strategies over the last few years and why BESS is becoming essential for them. So the journey would have started with load shedding and price volatility. At some point, energy shifted from being a controllable cost to a production risk. And this triggered a full reset of energy strategy at a board level. And the fastest response for most of these mining companies was to partner with either a renewable energy developer or an IPP, allowing them to move quickly, avoid upfront capex, and then lock in price certainty. Then where land and generation resources made sense for these mining companies, on-site projects were ideally suited as they offer the greatest potential tariff displacement and savings. But then as electricity costs increase and certain energy intensive operations, including smelters, were scaled back, closed, on-site projects were reevaluated because a lot of the original load assumptions fell away. And this really drove a pivot towards wheeling. wheeling offers much greater flexibility and scalability, and it allows energy to be redirected to other operations in a mining case, for instance, where the load falls away. But with wheeling, the wheeling benefit has also been steadily eroded by the Eskom retail tariff plan changes and tariff reforms. And then looking ahead, the proposed wheeling framework, which was released last year, talks about a move from monthly reconciliation to hourly reconciliation. And SAWM is also going to be an hourly market. So Cresco's view is that all energy contracts will move to an hourly reconciliation. And this will materially increase the excess energy, which further compresses wheeling savings. But this is where BESS becomes critical. It's not only for arbitrage, but to stabilize savings, to manage tariff volatility, and hedge against the reconciliation risk. Furthermore, the decrease in BESS capex over the last 2 years has also changed project dynamics, and BESS is now really being incorporated in most of these energy strategies. So at the same time, BESS also positions these large energy users for future market participation and revenue stacking. So you're really turning a tool you're moving away from a tool which is just used for risk management into strategic optionality, and then potential future opportunities for new revenue streams which can be realized in SAWM. So this is just a practical example showing a 60 megawatt PV system on its own, and then showing the same system paired with the 50 megawatt 4-hour BESS. And that's modeled against a typical industrial or mining load profile. And I think important just to note is that this is for an average day in the year. So one can expect more variation if you isolate the profiles in January or June, like previously shown. But on the left-hand side with PV only, you can see the familiar pattern, strong midday generation, but a significant portion of that energy is excess, so above the load line. And on the right-hand side, when we add BESS to the system, the excess midday PV is captured, it's shifted into the morning and evening peaks, and you can materially increase your renewable penetration during peak periods. So the result is obviously less wasted energy, a higher utilization of the PV plant, and then increased renewable energy penetration in peak periods. And the main benefit of BESS is not that it increases generation. The gross annual generation remains roughly the same, although there are some round-trip efficiency losses, which is taken into account. But nonetheless, the BESS increases the value per megawatt hour just by shifting consumption into the peak tariff window, like you can see in the bottom left figure. Now, translating that operational impact we just saw into financial outcomes, we assume a wheeling project with the BESS only discharging during peak periods, and then a base tariff of 2 Rand per kilowatt hour. So the 2 Rand per kilowatt hour is a very conservative base tariff, and the business case really only improves with lower tariffs. But in the PV only case, savings is largely only driven by the standard and off-peak displacement, with limited impact during the most expensive peak periods. But once BESS is added to the system, you can see that there's a clear reshaping of the demand cost stack, particularly in the winter months where the peak period grid purchases are materially reduced. So by adding the BESS, you're driving unit savings up from roughly 270 Rand per megawatt hour to close to 400 Rand per megawatt hour. And you're also significantly increasing the total NPV of savings. And then the largest increase occurs in the winter high season months, June, July, and August, because this is where peak tariffs and Eskom retail tariff plan exposure is the highest. But what's interesting in this case is that around 65% of the NPV of savings is attributed to the BESS, even though it only cycles about 500 times a year and it's utilized at roughly 57%. And this is where the reduction in BESS capex really comes into play, where previously BESS only made sense when utilization was in the order of about 80 to 90%. the reduction in CapEx cost for BESS now has two consequences. So firstly, the BESS value is now driven by timing and not volume. And secondly, there's meaningful headroom for additional revenue streams. So because the battery is not fully utilized, there's scope for future revenue stacking, such as ancillary services or other market participation, without materially undermining the core savings case. So for mining clients, mining energy users, BESS both amplifies the current savings in the most expensive periods, but it also preserves flexibility to capture future market opportunities. So let's look at the total value over a 25-year horizon, and critically how that value holds up as South Africa transitions towards a wholesale market. So in this analysis, we assume monthly reconciliation until the end of 2029, followed by hourly reconciliation from 2030 onwards. And like I said before, this is expected to apply to participants in SAWEM. And the key structural change when moving from monthly to hourly reconciliation is that excess energy increases. So under the existing monthly reconciliation regime, surplus energy within a given time of use period can offset shortfalls in the same time of use bucket elsewhere in the month. But once settlement moves to an hourly basis, that netting disappears, and any mismatch between your generation and load in a specific hour becomes either excess or shortfall energy, and that will have to be settled at real-time prices. So that increase in excess energy will directly reduce savings because surplus renewable generation will either be curtailed or settled at lower prices, while shortfalls will be exposed to peak tariffs and the Eskom retail tariff plan. So for PV without BESS, this results in a material drop in savings once hourly reconciliation applies under SAWEM. But with the system with BESS, however, the excess energy can be captured and redeployed into high-value hours, and this materially reduces the profile mismatch, which preserves savings even under the hourly settlement regime. So interestingly, in this analysis, the highest NPV of savings comes from using the BESS across both regimes. So first, for peak arbitrage under the monthly reconciliation, and then as a settlement risk management tool once hourly reconciliation applies. So the same asset shifts roles as the market evolves. So I guess in essence, for large energy users, BESS is not just enhancing returns today, it's also actively reducing excess energy and then future-proofing savings as South Africa moves towards SAWEM. So rather than ending with a recap, I rather want to close by looking forward at where we see the real opportunities for BESS emerging in South Africa. And in the near term, like I mentioned previously, we expect PV plus BESS to become the norm for new private sector projects. And this will be driven by grid constraints, curtailment risk, tariff exposure, and the move towards hourly reconciliation. And in this window, BESS is really only doing defensive work. It's managing peaks, reducing exposure to Eskom's retail tariff plan, and it's stabilizing wheeling economics. However, in the medium term, the role of BESS starts to expand. So we see as balancing responsibility shifts closer to market participants, BESS will start becoming a tool to manage settlement risk, and it will provide more flexibility. So we see most BESS projects being designed for some sort of optionality, incorporating some form of revenue stacking, and flexibility and not energy volume alone is what the grid will increasingly require. And beyond 2030, the opportunity broadens further. So as we continue to see coal exit the grid and gas availability remains uncertain, longer duration BESS becomes essential, and particularly to support the early morning demand and extended peak periods. And at that point, storage moves from sort of a customer optimization tool into more a piece of system infrastructure. So in closing, I think the opportunity for BESS is not just about today's tariffs. It's about positioning for a system that increasingly values flexibility, resilience, and adaptability. And that's really where we see the most durable value emerging.
Well, thank you, Neil. Really very insightful, giving us an understanding of, how the value proposition for BESS is changing, up to now and where it's heading for in the next years. And I think that gives some very valuable insights as to what we can expect going forward, and also give some clues to developers and customers as to where the opportunities lie in the years ahead. So thanks very much for that, Neil. And we're now going to move on to our last presenter before the wrap-up, and that is Jason Bruce Brand from SMA Altenso. So Jason is a business development executive at SMA Altenso, where he plays a key role in developing and delivering large-scale renewable energy, battery energy storage, and hybrid power solutions across Africa. With experience spanning utility-scale standalone BESS, co-location with renewable energy sources, grid-forming technologies, and complex project execution, he works closely with IPPs, utilities, and industrial off-takers. His role involves key account management, market development, financial modeling, and project development. Jason is legally and commercially driven and has a practical systems-level understanding of how renewable energy generation, storage, and power electronics interact within constrained and evolving electricity networks. So going to be really interesting to hear from an OEM here, an OEM and a system integrator that integrates these different components of renewable energy, battery storage, inverters, and all the tech that goes with that into solutions for the mining industry and other industries in Southern Africa. So over to you, Jason. We're looking forward to hearing what you have to say.
Okay, thanks very much, Chris. Pleasure to be talking amongst the panel today. I'm just going to be providing an overview today of SMA Altenso and some of our track record and experiences on the continent, as well as some of the solutions that we're working on, which are relevant to the mining sector. And what we're seeing is that, in line with what my colleagues on the panel have been talking about, there's a strong commercial case in respect of energy arbitrage and revenue stacking when it comes to BESS. But there's also a strong operational case for it, and we'll touch on that today. So just for a bit of context as to how our group functions, some of you will be familiar with SMA. So SMA is a leading renewable energy OEM from Germany and has been around for 45 years and is consistently at the cutting edge of power conversion technology. So, for example, SMA was responsible for inventing the string inverter over 3 decades ago, and more recently has been the first commercial company to commercially integrate silicon carbide MOSFETs technology into inverters, which has improved the inverter efficiency to market-leading levels at over 99%. And with that, SMA has over 155 gigawatt of installed capacity in 190 countries around the world. And around 12 years ago, there was a requirement from some of the customers within the SMA group to provide a broader scope of supply outside of just your inverter. So for customers that were looking in particular to go off-grid or integrate a variety of different energy sources into one system. And with that notion, a subsidiary was spun out of the SMA group, which was called Altenso. And Altenso was originally called SMA Sunbelt, which some of you may have heard of. And as the name suggests, it was initially to cater to customers in the Sunbelt region that were looking to integrate renewable energy. And Altenso has now grown from just that segment into large-scale or utility-scale BESS applications, and as well as green hydrogen, and is the fastest-growing entity within the SMA group. So I mentioned the three segments that Altensa focuses on. I'm just going to spend a little bit of time talking about our background and track record and how we got into these different segments. So as mentioned, Altensa started off with a focus on hybrid and off-grid projects. So this was using the popular SMA Sunny Island inverter, as well as the fuel save controller. And one prominent use case for these sort of projects was island electrification. So the picture you can see at the bottom there was an island in the Caribbean, which was running exclusively on diesel gensets to provide power to the 4,000 inhabitants on the island. And Altensa was brought on board as a technical partner for that project to integrate renewable energy and reduce their reliance on the diesel gensets. And over 3 phases, we successfully integrated 7 megawatt of PV and 10 megawatt hours of BESS with grid forming and black start capabilities. And the island can now run completely off of renewable energy during the day. And these sort of projects, although they seem more straightforward than your complex grid-tied projects, are actually a lot more complicated and challenging in the sense that you essentially become your own utility. So we really sharpened our teeth with that project and went on to do a lot more island projects after that. And our business model then evolved in 2017 when we were awarded the EPC contract for the first grid-connected battery in the UK, which was called the Pelham project. And at the time, that was the largest utility-scale battery project in Europe at 50 megawatt hours, which in today's standard is quite small, but it was a big project at the time. And Altensa executed on this project in 5.5 months from contract signature. So really did it very efficiently and effectively and got a name for ourselves when it comes to utility BESS. And this has now become our largest segment by far, with now 1.5 gigawatt of installed large-scale BESS applications internationally. And we've got a multi-gigawatt pipeline when it comes to BESS. I won't spend too much time talking about power to gas, but I'll just say that this is a business avenue where we've also gained a lot of success, and we're actually the only company in the world to reach 1 gigawatt of delivered conversion power for green hydrogen applications. So an interesting project I can just mention in that regard is the project you can see at the bottom, which is the first green ammonia plant for fertilizer production in Europe. And that essentially entailed Altensa coming on as a system integration partner to integrate 100 megawatt of solar, 8 SMA electrolyzer conversion stations, and 16 PEM electrolyzers. And it now produces 3,000 tons of hydrogen per annum. So I mentioned that we've got a bit of a track record and quite a strong foothold when it comes to the utility BESS landscape, both as a system integrator and a fully fledged EPC. But we've also gone further down the value chain and actually done our own greenfield development of projects. So the first project that we did of this nature was the Metalin project, which you can see in the top there. And that was a 230 megawatt hour system for frequency management services in Germany. And essentially there we worked with the local municipality from the greenfield stage and worked and developed the project up to COD, and then sold off the project to a large reinsurance company in Germany. But we retained the full EPC and O&M obligations for the project. And that's a model that we've gone on to replicate quite a few times in Europe, and we're looking to explore that model in Southern Africa as well. And in the last few years, we've also gained quite a bit of traction in terms of the projects we've been afforded to work on in Africa. So I'll just touch on 2 of the quite interesting projects that we've been a part of. The first is the Cleanergy project, which was the first completely off-grid green hydrogen refueling station in Africa. And that was done in Walvis Bay in Namibia, in which we came on board as a system integration partner and integrated 5 megawatts of PV, 5 megawatt hours of BESS, and a 5 megawatt electrolyzer for the pilot phase of that project. And the objective and the rollout plan for that project is for it to reach a gigawatt. And there's essentially an anchor developer there, which is a Dutch shipping company. And they want to use the green hydrogen, or rather the green ammonia, to fuel their shipping fleet. And another interesting project that we've been a part of has been a large rural electrification project in Angola. So that's currently ongoing, and we are essentially working on 48 different sites across the country, cumulatively totaling 300 megawatt peak of solar and 700 megawatt hours of BESS. And that's a project which is ongoing at the moment, and we commissioned quite an interesting project at the end of last year, which I'll touch on later. And so with this growth on the continent, we've launched a subsidiary in Cape Town in South Africa. And we've also unlocked a multi-gigawatt pipeline in Australia, which has led to us also opening an office in Sydney last year. So I'll focus on the BESS segment today as it relates to the webinar topic. But Altenso has now executed over 60 large-scale BESS projects and has never missed a project deadline. And generally, we would come on board as a system integration partner, or in some cases an EPC, and provide bespoke design and engineering services, and then supply the related hardware up until the point of interconnection. So this would include your SMA PCS at its core, and then we work with strong tier one battery manufacturers, which we have framework agreements in place with. And we're also able to support with on-site and remote commissioning, as well as a full suite of O&M services. So I just want to spend a minute to talk about grid forming technology and why this is a buzzword in the BESS landscape at the moment, because it ties into one of the solutions that I'll be talking about later on. So essentially, grid forming technology refers to power electronic systems that can actively establish and regulate grid voltage and frequency. And this is in contrast to your traditional grid following inverters, which have been used in the majority of renewable energy projects in the past, in the sense that they simply follow an existing grid signal and would trip in the case of a blackout or a grid fault. So unlike your traditional grid following inverters, grid forming inverters behave more like a synchronous generator. They set the reference for voltage and frequency and are able to respond dynamically to changes in load and system conditions. So this is going to be of growing importance on the grid level, particularly as Eskom phases out its spinning reserves in South Africa. That's our coal-fired power plants, and adds more renewables. There's going to be inherently a lot of loss of inertia and system stability in the system. And so batteries and grid forming technology is a great way to address that. And that's being done internationally. It's something that I know that Eskom is looking into, because they're engaged with SMA and Altenso to understand what is best practice from a grid perspective when you implement grid forming projects according to different jurisdictions in the world and different grid operators. And so that's not only important from a grid level and from a total system perspective, but this technology can also be used by industrial customers to essentially enable an energy security from the grid using grid forming technology and black start functionality. So just to provide a little bit of an overview of what the current topology of medium voltage grids would be, essentially your mining companies or industrial companies would typically connect between 6.6 and 33 kV and rely on Eskom or municipal supply, but then have a diesel genset as backup. So a Wood Mackenzie report I saw indicated that there's conservatively over 100 gigawatt of installed diesel genset capacity in Africa. And other sources indicate that over 10 gigawatt of that can be attributed to the mining sector. So that's the sort of normal layout in the African industrial context. And the challenge that a lot of mining customers would face is that they're often in remote areas at the end of transmission infrastructure, if they have grid available at all. And that results in unreliable power supply. And so this would also be exacerbated by large inductive loads that you might have on site, like motors and drives, which create a lot of harmonics in the system. And so the upshot of these weak grid applications is that a grid fault of only a few seconds can cause a trip, which results in your facility being offline for 5 or 6 hours at a time. And the downtime is obviously very costly in itself, but that also comes with safety risks and potentially wasted raw materials. And even when there isn't a trip or blackout event, the poor power quality that you're getting from the grid can still damage your sensitive equipment on site. So with this problem in mind, our team of engineers at SMA and Altenso have come up with a solution that addresses these challenges directly through the use of batteries, grid forming technology, and potentially paired with other renewable energy sources. And it's essentially to address 3 core requirements. The first is to mitigate an industrial end customer's exposure to the grid and grid disturbance events or blackouts. The second is to reduce some of the operational costs and headaches associated with getting diesel to site and relying on it exclusively as your alternate energy source. And the third is to improve on a company's sustainability and ESG metrics while still getting them reliable power through renewable energy. So just from a high level, I'll just go over some of the system and the solution components. So the solution would essentially include a SMA PCS in the form of a medium voltage power station. So this is a plug-and-play 20-foot skid, which includes your Sunny Central storage inverter, and that ranges between 3.5 to 4.6 megawatt AC output, and also includes your switchgear and transformer. And then you would also have a decoupling choke, which essentially acts as a coil or single-phase transformer and is able to sustain the voltage at the point of interconnection in the event of a grid disturbance fault. And of course, you'd need your battery container from the likes of CATL, BYD, and others that we work with. And the benefit of working with Altenso is that we're a one-stop shop for all of these components. So you would be working with us directly, and we're also able to work on the overarching energy management system required using the power plant manager at its core. So here's a basic schematic of how the typical system would work. Generally, there would be 2 MVPSs converting DC power from the batteries to AC and connecting on the DC bus. And the system would essentially run in parallel with the load. And this would contrast your typical inline UPS or double conversion system, which is sometimes used to provide uninterrupted power supply to critical industrial loads. The benefit of this solution is that you're able to provide uninterrupted power to your whole load. So the solution essentially acts as a power stabilizer and not just a power conditioner. And an additional benefit would be that you get uninterrupted power on the MV level, but you can also oversize the batteries and implement energy arbitrage or peak load shaving. And this is something which is obviously of growing relevance as Eskom keeps increasing its tariffs. And we've seen some very strong commercial cases for energy arbitrage using batteries from some of our industrial customers. So just to provide an overview, in the event of a grid disturbance event, the grid forming inverters would step in with support of the decoupling choke, and it would maintain the load voltage within a stable tolerance band without the system tripping. So we've done extensive tests, and the solution, regardless of whether it's a 3-phase, 2-phase, or single-phase fault, the system's very robust and is able to handle all fault scenarios. And then if the grid doesn't return within 300 milliseconds, the system will then smoothly island itself and run off the battery capacity until the grid returns, or if needed, until the gensets start up. So this solution wouldn't only be relevant to the mining sector, but also other industrial customers running sensitive loads, such as manufacturers, data centers, agri-processors, and others. I'll just quickly talk through a test case from a simulation we did for one of our customers. And a caveat I'd say here is that if you're interested in this sort of solution for your business, one of our engineers will be able to run a similar simulation for you. So you're more than welcome to reach out. So you'll see on the left here, there's a graph that's showcasing the system voltage. The black line shows the grid voltage, which is at 22 kV. The blue line shows the inverter voltage, and the pink line shows the load voltage at the bottom here. And in this case, we simulated a 3-phase to ground fault at 10 seconds, and the grid voltage, as you can see, drops to 0. And you can see that the inverter provided an immediate response and increased its reactive and active power to compensate the load voltage and frequency. And so if you look at the highlighted yellow block, you can see that the load voltage remained within the tolerance band of plus minus 10% without any supply interruptions, and frequency also remained in the stable range, as you can see on the right here. So essentially what you're seeing is that the system responds immediately with no delay and is able to stabilize the frequency and voltage ranges throughout the fault, and thereby provides uninterrupted power supply. In this image, I'll just showcase, this is an island mode scenario that we simulated. So this would be a case where the grid voltage doesn't return and the system has to switch to island mode. So after 500 milliseconds, you can see that if the grid doesn't return, the system will island itself in accordance with grid code standards. And the little bump on the inverter voltage shows that the main breaker was opened and the system went into island mode, meaning the inverter is completely responsible for providing active and reactive power to the load. And if you look in the yellow block here, the image here shows that the islanding is seamless. And by seamless, I mean that the system holds the voltage and frequency of the load within stable ranges. So when the grid voltage does return, the system will then automatically switch back from island mode and synchronize back to the grid seamlessly. So just one other point, I mentioned that we would come on board as a technical partner for the project in terms of the design and supply of the equipment. We would also offer a full suite of multi-vendor O&M services for PV and BESS applications, and have a local service team here in South Africa and other service partners throughout Africa. And we'll also be able to walk through the design life of the system you require from the beginning. So factoring different round trip efficiency and state of health considerations related to the battery, and essentially address the problem that you're trying to solve from the onset. And we're also happy to provide a high-level techno-commercial analysis on the return of investment you might be able to expect integrating renewable energy and BESS into your system. I'm cognizant of the time, but I just want to mention 2 projects. So this was a mining customer that we worked with in Western Australia, which suffered from very weak grid conditions. And we're looking to integrate renewable energy, reducing their reliance on diesel and a gas turbine on site. And in this case, we integrated 38 megawatt of PV and 5.4 megawatt hours of BESS with grid forming and black start capabilities. And we're able to assist with the stabilizing of their power supply, essentially, in this case. So essentially highlighting what I'd discussed prior. And I think I'd also just mention that we've worked with similar mining and industrial customers in South Africa with our local team. So it is applications that we are familiar with. And then lastly, just a project that's quite interesting. So we inaugurated this at the end of last year, which is the Kazombo off-grid site. So this is the largest off-grid PV plant in Africa, and it relies exclusively on PV and batteries with grid forming technology. And so there's no diesel gensets on site. And this is now providing 24/7 power to 136,000 Angolans for the first time. And one thing that's interesting about this project is that because of the funding requirements, there was a requirement that all the content had to come from Europe. And so we actually integrated the battery containers at our SMA headquarters in Germany. And so that just sort of shows the engineering capabilities of Altenso, and the work that we're able to do from our factory. So that's my time. Thank you very much for listening. If there's any questions or if there's projects that you want to discuss, please feel free to reach out to me over email. And if you are attending Mining Indaba next week in Cape Town, we'd love to meet with you and discuss your project. Thank you, Chris. Over to you.
Thank you, Jason, for a roundup of the really innovative projects that you've been doing and your capabilities, from microgrids through to completely standalone microgrids, as you mentioned in Angola, through to the other projects that you've undertaken in the battery field, and even in the power to gas field, the hydrogen field in Namibia. So some real interesting projects, both internationally and in the Southern African environment. So now I'm going to introduce to you the lady who is going to do the wrap up, give us some insights, and that is Ntabiseng Mosia. Ntabiseng is a trailblazing social entrepreneur, and she's a PhD candidate at the UCT Graduate School of Business Power Futures Lab. And she focuses on renewable energy procurement and investment in South Africa. As co-founder and chief commercial officer of Easy Solar since 2016, she has led the company to provide clean energy access to over 1 million people across Sierra Leone and Liberia. She is named Outstanding Social Entrepreneur by the World Economic Forum in 2019 and the Young Female Entrepreneur by Forbes Africa in 2020 and Bloomberg's New Economy Catalyst 2021. And she brings valuable practical experience to her research on the just energy transition. She has a master's in energy from Columbia University and a BSc in finance from the University of Cape Town, both with distinction. So I can't think of any better person, an independent person to come to the table and give us a few insights to wrap up this webinar. So over to you, Ntabiseng. We're looking forward to hearing your words.
Yes, thank you so much. I have the daunting task of wrapping up after some amazing presenters today. So as Chris introduced, my name is Ntabiseng Mosia. I'm a doctoral researcher at the Power Futures Lab, and my work focuses on renewable energy procurement and investment, so very relevant for what we're talking about today. So I thought about just wrapping up and concluding our conversation into 5 buckets. So really looking at where the mining sector fits into what we're seeing in procurement trends. And that's, the Power Futures Lab, we have a IPP database that we've been tracking really since REAP. And so seeing what contribution the mining sector is making just in terms of volumes. And then looking at the drivers that have been spoken about, who are the actors, which I think hasn't been spoken about as much, since I think everyone's been focused in their narrow lane and speaking from their perspective. And then highlighting, I think, a few bottlenecks came up and future developments. So yeah, just in terms of our own database, so we've been, as I said, been tracking IPP procurement really across sub-Saharan Africa, but we have quite a rich data set in South Africa. And what we've been seeing is a trend in the country of private offtake contracts outpacing and more recently dwarfing public procurement. So really you can see in 2025, virtually most of the projects that reach financial close that were publicly disclosed are really on the private side. And so mining really fits into this, and it's what we're seeing as one of the key drivers of private procurement. I think a few things have been spoken about today, one being just the deregulation and the policy environment, so the ERA amendment and lifting of licensing thresholds, as well as more market-based concerns. Load shedding was really a key contributor. It was mentioned a few times that was one of the key drivers, really prompting the mining sector to consider it, in addition to rising electricity tariffs. I think it was Neil from Cresco who had a great quote which said, electricity went from a controllable cost to a production risk, and there was this desire to lock in price certainty. And last but not least, we're seeing really aggressive net zero commitments, also driven by this need for global competitiveness with policies like the CBAM pushing a need for net zero and decarbonisation. And what we can see is the graph on the right just shows just the scale of projects that are set to reach commercial operation this and next year. So we're really seeing, I think, the beginning of the story, and we're going to see a lot more of these projects operational. In terms of who are the actors, we've seen that mining companies, are really amongst the largest off-takers of renewable energy in general when we're looking at private procurement, and this is dominated by a few key players. Some have entered into joint ventures with developers. Some are, looking at a standalone pipeline and working with multiple developers. But we're seeing, pipelines from 500 megawatts up into the gigawatt scales in the case of Anglo American through a JV. And a really key trend is this, and it's spoken about a lot today, is this, the rise of multiple off-takers, either through a one-to-many, like the Solar Group has done, or through aggregated contracts. And this is really not just applicable to the mining sector, but generally we're seeing that. But what we're seeing is that it is still a concentrated market. So there's a small number of developers dominating renewable energy supply that are offering services to the mining sector. And it's been spoken about as well a lot today that trader aggregators are really playing a growing role. And you can see in the visual, the likes of NOAA and Discovery Green really taking up a lot of the development and generation projects in aggregation. So when we look at some of the drivers and constraints or opportunities, I think it was spoken about by Dr. Dlamini, where you have this, drive between wheeling and behind the meter. And, some of it is, just speed to market and cost versus, energy security and operational resiliency. But what we're seeing in the data is that wheeling projects are really dominating most of the publicly disclosed projects. Obviously, the privately disclosed ones might skew that a little bit in the other direction. And, wheeling does offer the benefit of geographical diversity. You get access to the best solar and wind locations. But I think a few of our speakers today have spoken about really this opportunity in BESS. I think this is really a nascent market. Most of the projects we've tracked to date have not had hybrid solar or wind plus BESS. So I think this is really the beginning. And this is driven by both grid capacity constraints, some of the reforms on the tariff structures that was mentioned already, and this need for increased flexibility to optimize energy utilization and your profiles, and then for future opportunities when it comes through the wholesale market for both energy and then balancing and ancillary service revenue options. So really a dynamic market that is fast evolving. And what I wanted to kind of just wrap up those key takeaways. I whizzed through those, so hopefully you guys are following. Mining is really a critical sector. It's a cornerstone of South Africa's growing private renewable energy market. And I think we're really at the beginning of this story. From the drivers, we've seen both policy reform and market fundamentals are really driving uptake, and alongside ESG considerations. But really, I think those two have been more of the impetus. And we see, flexibility and storage through BESS will allow for further unit savings in the immediate term versus renewable energy only projects. So we expect to see more projects coming on with BESS. And I think a lot of the more technically sophisticated on the engineering side speakers have spoken about just those optimization benefits. So the market is concentrated. I think that's not just something we've seen with private procurement. I think on the public, there was slightly more diversity, but really bankable, respected off-takers have been dominating, as well as aggregation structures through trader agreements. It was spoken about several times, both in the opening address by Christian, and then reinforced, I think, by everyone about the grid constraints and transmission build-out being really a critical factor to sustaining future growth. And then future developments, both on the technology and the market side. I think SAWEM will allow for price discovery. A lot of these private deals, as opposed to REAP, you just don't have a transparency in terms of tariff structure. So I think price discovery will allow for tariff optimization and then new commercial opportunities for those who are able to offer more flexibility and reduce settlement issues through balancing and then ancillary services as well. So that's my summary. I tried to take our own data as well as the amazing insights from our panelists. Over to you, Chris, and looking forward to the Q&A.
Yeah, and what a great wrap up that was, Ntaba Singh. Really beautifully articulated coverage of what we've heard today with some of your own specific insights. So I want to thank you very much indeed, for helping out and standing in and doing the honors of the wrap up. Really highly appreciated. Colleagues, we're now into the Q&A session, and quite a lot of the questions have already been answered. I see 27 answered questions, 6 still open. I'm going to tackle a few of these and maybe ask a few questions of my own based on what I've seen in the Q&A. So I'd like to ask all our presenters to please switch on their cameras so that we can see who is online, and I can then pose one or other of the questions to one or other of the presenters. So I'd like to pose this first question to, let me just get it in front of me, to Jonathan. Jonathan from Solar Group. Jonathan, a question here from Jan Keenan, who says the following: is solar looking at, that is the Solar Group, looking at using solar to address thermal energy needs in mining by using power to heat solutions such as heat batteries, as opposed to a chemical battery, a thermal energy storage battery? And I suppose this also gets to the subject of concentrating solar power, which can use either liquid salt as a storage medium, but there are other solutions, including these so-called heat batteries, which I think use things like rocks and steel and other medium to store heat and then deliver it to production processes, whether it's mining, chemicals, or other industrial processes. How does solar look at thermal batteries as opposed to chemical batteries?
Yeah, thanks, Chris. I think that's an interesting question. I suppose, look, as a company, we are focused on delivering electrons to the network. So we don't specifically look at that as a sort of an opportunity at the moment for ourselves. But what we have been doing, which I think is quite interesting, is we've been assisting some customers to evaluate how they would make those types of technologies work. And I think there are some very interesting examples of thermal batteries, especially where you start to move to having a wholesale market where you potentially have access to surplus energy at certain times that has a very low value or can be bought at a very low price, particularly in the future in the daylight hours. So we've seen some interesting technologies emerging there, and I think that the market, the opening of the market might be a bit of a catalyst for those types of technologies as well, where you can access potentially surplus and very low cost energy at particular times of the day.
Thank you. Look, I see another question here, which I'd like to direct to Christian, if I may. Christian, are you online? I don't see you there, but you may be there if you can switch on your camera.
Yes,
I see you there, Christian. Okay, so this one is directed at you. It's from Nimrod Zalk, and he asks the question: approximately what percentage of mining electricity supply is currently, hang on, I've lost the question now, just bear with me. Approximately what percentage of mining electricity supply is currently from renewables, and do you have rough forecasts of what percentage that could be for 2030 and to 2035? So it's kind of looking at the renewables penetration in the electricity usage in the mining industry. Do you have any kind of data on this, or even just some rough ideas?
I think we've surpassed 1,000 megawatts from what has come online in terms of units from solar, Sibanye that you've heard of. I would roughly estimate about 1,500. And in the next 5 years or so, we're looking at about 6,000 megawatts.
And what percentage of that is that of the the installed capacity, or of the electricity supply to the mining industry as a total? I think what the question is how significant is renewable energy in the overall electricity energy mix of the mining industry?
Remember, this is going to be a small amount, because remember, with renewables, you're actually going to use 25% of that. So if you're talking about 6,000 megawatts, you're probably looking at something like 1,500 megawatts if it was a baseload station. So it's not all of that that's going to. So that would be very small amount.
Yeah. Okay. Thanks for that. I'm just scrolling through some of these questions here. This is an interesting one. It may have been already answered, but I think it's worth asking again. The question, perhaps we could direct this to Muzi if he can help out, and if he can't, maybe one of the other presenters can. The question really relates to the energy intensive users of South Africa, and that's why I chose you, Muzi, because you've been a chairperson of the energy intensive user group. These smelters that are shutting down, we've heard that about 50% of the smelters have shut down. I think Muzi gave us that figure. Sorry, Christian, I think, gave us that figure. A question I'd like to ask is that if the price of electricity was dropped, as it has done now, to, I think, a 30% price discount, but the smelters want more. They want to drop down to 62 cents a kilowatt hour, which basically represents approximately a 70% discount of the price of electricity that they're currently paying. I don't know how they're going to do it, but if they do it, how quickly could the smelter industry come back on stream, and what would be the increase in electricity demand? In other words, what would be the impact on our ability to meet demand if this smelter demand suddenly came back on again as a result of meeting the prices? Have you got any thoughts on that? Just rough figures, Muzi?
A difficult one, Chris, in terms of the specific numbers, but certainly the price, if you are an energy intensive user like the smelters, is one of the most significant, usually top two, either labor or the energy costs. And we compete with international players in a lot of these spaces that do have more favorable pricing regimes. And one of the things from an energy intensive users group perspective that we've been looking at is the whole question of affordability and sustainability, because what we are starting to see, even before this sharper drop-off of smelters, was we are deindustrializing as a country, and it's a direct consequence, let's say largely, to affordability. So you can see from the sales and the decline in Eskom sales, as well as the reduction in the number of large power users as customers, that this is actually something that has a real impact. And the price elasticity, I think, in this aggressive increase path was underestimated, because we are seeing that there are businesses dropping off. So certainly better pricing will help us reindustrialize. It's difficult to say in terms of what percentage of demand comes on, because there would be some assets that were maybe under care and maintenance quite a while ago, and those might be at a different level of, let's say, readiness, and might require some capital investment to come back. But certainly the more recent ones, those would be able to come back. And this is now being seen in that there is excess energy in the grid because they are actually less energy intensive consumers. So I think it would be twofold. First, it would be to take up the excess. I think an improved performance by Eskom and the private procurement and projects that are going in are increasing what's available. And certainly, if it contributes to a downward price path for those sectors, it will help them come back online.
Yeah, what I think the question was getting at that I saw on the question list was, currently, because of various factors, we have a whole lot of generation that is in cold reserve, effectively shut down, because we actually now have moved into an area of surplus generation capacity, and that's and the question I'm really thinking is, could this surplus be rapidly mopped up if the smelters could get the price that would make them internationally competitive? Could this surplus just be mopped up and we get back to a stage of shortage again? I don't know how big the smelter load is in total, or was, let's say, at the heyday. And I'm just wondering if this a rapid uptake again as a result of price could push us into shortages again.
Certainly, there would be that consideration. It's been a significant contributor to the base load, and in theory, if all of them were to come back, we would be in a constrained situation again. And I think that features in some of the modeling in the IRP that certainly, if it is enabling and those can come back on, we are still in a tight corner where we do need to rapidly deploy capacity. When we couple that with what needs to, from the Eskom fleet, be shut down. So it is a balance that we're able to navigate because of, to a certain extent, reduced demand. Unfortunately, Chris, I won't venture into the figures.
No, understood. Look, I've got another question here, which
sorry,
I'd
Chris.
like to...
Sorry, just to add to Muzi. So, yeah, so the stats, we're struggling with the stats also because of collection by government, by the GMPR. But I mean, so like he was saying, the ones that have closed shop in a year or two ago that are in care maintenance can come on. We've seen there's a couple of them, although they don't get to that, like, let's say 20% or so of the current installed capacity of smelters. So they will come on, but it's only those that have been recently closed. Other ones have already been cannibalized and sort of shut off and leveled off. So it's not all of them that can come on back online.
Yeah, thanks. Understood. That's interesting observation that I hadn't thought about, that some of these smelters are beyond coming back because of, maybe they've been cannibalized, as you said, or just fall into disrepair to the state where it might not be economical to actually bring them back. I'd like to put this question to Jason, if I may. Jason, this is a question from Jean-Claude Malobi. And he says, I'd like to ask Jason if they're interested in developing a PV BESS solution in the DRC, similar to the one developed in Angola, especially in the mineral regions such as Kolwezi City region and the Lubumbashi region. And the country needs a similar project developer. So, hell, it sounds like a hot inquiry there, Jason. But yeah, it gets to this idea, in the mining industry in Africa, sometimes are remote from the grid. Sometimes the grid is very unreliable. Sometimes a microgrid solution is needed for the mine, either to supply the portion of demand that cannot be met by a grid connection, or sometimes even a fully off-grid islanded solution. Is this something that you would consider, Jason? Are microgrids in the mining industry your business?
Yeah, thank you very much for the question, Jean-Claude and Chris. So we're actually working on a similar project in the DRC at the moment, which is a microgrid for a small mining town. And the answer to the question is that we wouldn't come on board as a developer per se for a microgrid solution. We generally work with a third party to develop the project. The projects that we'd generally develop in South Africa would be your utility scale BESS applications, but it's definitely something that we are familiar with as a technical partner. So to answer your question, we can definitely engage with it. We do have a host of partners that we work with to develop those sort of microgrid solutions. But from a technical point of view, that's definitely within our strengths.
Mm-hmm. Thanks for that. And this one is to you, Neil. If I may pose this question to you, it's one of my own questions, but how important, are the role of traders to customers in the mining industry? I mean, mining companies are very often large companies that can do a 20-year PPA direct with an IPP and a wheeling arrangement. But I guess there's quite a lot of mines that maybe are somewhat smaller, and a 20-year PPA is just not on for them because of the the uncertainty of the commodity price that they're mining, and maybe there's a role for traders there that can buy from large IPPs and sell to a whole basket of smaller off-takers in the mining industry, on shorter PPAs, maybe 5 years, 10 years, or something that is palatable to the customer. And is that not the role of what a trader is? To have a diversified basket of off-takers that enables it to offer shorter PPAs as opposed to a one-to-one wheeling arrangement. So question, how important do you see the role of traders in the emerging role of traders in the mining sector?
Yeah, thanks, Chris. I think you've sort of nailed it on the head. I think it's important. We see a lot of mining clients interested in shorter term PPAs, and really that's, I think, the competitive advantage that traders or aggregators can offer them. Maybe at a bit of an increased tariff, but at least then you have that risk, or the risk is mitigated where you can have a shorter term PPA, and it offers flexibility. And I guess to a lot of what's been spoken about now, is that volatility in commodity prices, energy prices. Mining clients are more and more looking for shorter term PPAs just to mitigate for that operational cost risk of the future.
Yeah, thanks for that. I think you've sort of confirmed my own feelings on the subject. So next question I'd like to put to Jonathan. And Jonathan, I think you've had practical experience of this in the Springbok project. That it's been mentioned also by Muzi, at Sibanye-Stillwater, who had some involvement in this project as well. And that is, I want to discuss and we maybe bring in Muzi. We maybe bring in Christian as well in on this. But let's start off with you, Jonathan. This conflict between surface land rights and underground land rights that we saw play out with Renogen and Solar Group over the underground rights that Renogen held, which seemed to create a conflict with the rights that were granted to Solar Group to develop the Springbok project, on land where the Renogen company owned the underground gas rights. How prevalent is this issue across other geographic areas or other projects, or is this just a unique project, a unique situation that involved this particular project, or is there a wider project where people with underground rights are in conflict with renewable energy developers like yourselves and others?
Thanks, Chris. Yeah, I mean, I think it's probably a little bit of a symptom of the growth and the maturation of the of the solar and potentially the wind sectors as well. There's a lot of land use involved, and there are land in South Africa is used for agricultural purposes, mineral purposes, and now also obviously power generation. So, and some of these activities cover vast areas, and obviously mineral rights, especially prospecting rights, can cover huge areas. So I think it's a little bit of a growing pain, maybe just to work through that. There's also systems maybe that need to be developed and adapted to better coordinate these types of things. But I think we navigated through that, and we landed in a pretty good position following that. And I think it's helped for us in terms of our other projects. It's just allowed us to have a framework to manage those risks a little bit more clearly. It was a little bit of a risk that's come on the back of the growth of the sector, I would say.
Yeah, thank you. And I'm pleased that there seemed to have been some kind of a settlement finally reached after lots of backwards and forwards and legal action, etc. But in the end, an out-of-court settlement seemed to have reached. And maybe we can just bring in Christian here. Obviously, more knowledgeable about the mining rights and the exploration side. How are your members bumping heads with the solar PV and the wind developers?
Look, I think for us, the MPRDA would want to make sure that the minerals under the ground is mined out. And so you do a similar application if you're building also on a mining area. And normally the DMPR would approve it. So we haven't had a lot of cases where this has become problematic because it would be put at a side where either mining has already occurred and the area is free, or the area has been rehabilitated, and so you can put those panels there. What I've seen in the Free State, Carltonville area is that they put them sometimes next to or on top of sludge dams. And so it doesn't affect your mineral rights.
Yeah. And while you're there, if you could just stay on please, Christian. There was a question that really related to sort of land that mining companies own that might be, what I might call badlands. In other words, it's environmentally damaged land as a result of past mining activities, etc. To what extent, is this kind of land made available for renewable energy developments on a faster scale? Because it is bad land, so you may not have to go through the full environmental sort of authorization process that you might expect with virgin land that is in good condition. To what extent is this bad lands thing an opportunity for the mining industry and for developers?
Yeah, with mines at around closure, you'd want for there to be social labor projects, and the social labor projects can entail things like farming, any type of business that you could run on that land, and so projects like solar could actually give value to communities around those areas. Most of this land is normally rehabilitated to almost its original position. So maybe back then it wasn't done, but currently we rehabilitate land to almost where it used to be. And so cattle farming and those things still occur on that particular land. And so this land could be used. The only difficulty is this land is owned by a particular company. And it's not like when Ascom says we're opening up the land to everyone. If you want to set up your solar panels, come and set them up. So when you go into negotiations with those companies, that's how the difficulty comes. So I remember one case where I spoke, I'm not sure if it was solar or any one of the other companies, that the owner of the land was then saying, how much are you giving me as a percentage of your plant, or how much revenues are you producing, instead of saying the land is worth this much. And so that would be open to the company negotiating. Yeah.
Thank you. Look, colleagues, we are slightly over time now. It's just it's 16:34, but I just thought that maybe we will take one or two verbal questions. If anybody wants to put their hand up in the audience and ask a question, please put up your hand. I see one already, but if there's one or two, I can certainly take these questions. So the first question is from a regular listener at our webinars, and that is Michelle Rivarola. Michelle, I've switched on your, well, let me see. Yeah, your microphone. Please switch your microphone on and ask your question.
Hi, Chris. I'd just like to make a comment. I keep on hearing, this issue about LNG as for peaking plant and so on. But what baffles me is that in the presence of so many technically qualified people, when CBAM is going to come into effect and Scope 2 and Scope 3 emissions are going to be factored in, all those fugitive losses in the well to burner cycle and all that unburnt methane that is released into the atmosphere are going to come in. And all of a sudden, instead of having a fuel that maybe burns more cleanly than coal, you have a fuel that is going to produce somewhere between 5 and 10 times more carbon dioxide than burning 1 kilogram of coal, because when you burn a kilogram of coal, you don't produce 1 kilogram of carbon dioxide. I mean, unless you burn everything, that never happens. So I was saying, just beware about the future of CBAM and what LNG is going to do to your Scope 2 and your Scope 3 emissions, because those have to take into account the fugitive losses, which at 6%, with a global warming potential of 80, gives you a factor of 5, or pretty close to 5 already. So it's not a clean fuel by any stretch of the imagination. It might be clean for the fossil fuel industry, but that's about it.
Yeah. Let's put this question to Neil, because Neil mentioned gas to power as a necessary a source of flexible power, in future years, to complement, as a longer term sort of storage option to the shorter term battery option. And so he kind of mentioned this in his presentation. Neil, would you like to just quickly respond to that point that is made by Michelle?
Yeah, Chris, I'm not that close to gas technology and LNG, but I think from just a grid perspective in your energy mix, you want to have a correct mix of energy. So we don't want to have an over reliance on one technology when there's other technologies available. But at the same time, I hear what Michelle is saying, and from a green and emissions point of view, there's other considerations as well where BESS might be better suited from an emissions perspective if you can charge it with PV or wind. So definitely from that perspective, I think BESS is a better option. But again, from a technological and energy mix on the grid perspective, it's probably, there's other considerations, like I said, to have, a better mix of technology than just relying on one or two.
Yeah. Now, I'd like to turn this thing around on its head before I go to Guy Richards, and put this to Ntabiseng, if you can handle it, Ntabiseng. And that is this, to turn this idea around. We've got these OCGTs, open cycle gas turbines. They operate on diesel. There's 4 plants, the Avon and the Disa, and the Garikwa and Ankerlag, which are, peaking plants, but have been used in the past to run for quite extended periods, well beyond peaking plants. And my thought is, what about introducing some battery energy storage hybrid OCGT so that they use less diesel and use battery for the, let's say, 4-hour kind of storage operations, which is probably the majority of the case, and use the diesel OCGTs as a longer term, when you have a longer term outage or you need to run for longer. And now we're not using gas to power that increases emissions. We're using batteries together with diesel to power to actually reduce emissions. Is there any kind of a business case, for a hybrid battery and gas to power?
Yeah, I mean, at a high level, I'm just wondering sort of what the rationale is. That you're talking about it from a price or an emissions perspective? Because I mean,
actually both, because there is a cost to emissions, a cost of the carbon tax, a cost to CBAM and all of these things. But the whole business case, could it make sense to introduce some BESS at Ankerlig or at one of these stations to reduce your diesel consumption, which is hellish expensive, to reduce your carbon emissions, which also are expensive or growing in cost? Of course, batteries are expensive too, but maybe the balance favors a hybrid solution. I don't know the answer.
yeah, I mean, my understanding, I mean, batteries from they're not really a generation asset, right? So you're from an emissions perspective, I don't think you're necessarily solving the issue. I think you're dispatching it probably from a locational or from a time perspective, you might be able to optimize, but you can already, there's that flexibility with gas anyway. So I'm not really sure. Maybe the other colleagues can answer sort of the rationale behind it. I'm not, yeah, I don't really see having two flexibility assets side by side that can necessarily offer the same services. Whereas I think with renewables, it's more solving the intermittency and there's sort of price optimization. And so I mean, maybe I'm missing the point. So from an emissions and a pricing perspective, I don't see the benefit, because one is solving, an intermittent.
Let's ask Jason if he can
Maybe,
add any thoughts, or maybe I've got, maybe my thinking is round the bend, which is quite possible.
Yeah, I'm also not too close to this space, but I would tend to agree with Ntabe saying. I think it doesn't really make too much practical sense, in the form of you would be essentially burning the gas and then converting it again. So it seems like it would be.
No, that's not what I'm saying. Use the grid electricity when it's available to have batteries charge and discharge the batteries for short-term needs, for peaking.
Yes.
And then use the gas, for longer term needs if you would need to run it for extended periods. I don't know. Look, I don't want to labor the point, because I'm very ignorant about these things. But I just thought that maybe you had some insights.
I'm not sure. Yeah, I'm not sure of the use case there. I know that we've done projects in Europe where we pair batteries just to smooth power from gas plants, and it's great for that use case. But I'm not sure about the use case you've mentioned.
Okay, no problem. Look, let's move to Guy Richards, whose hand is up. Guy, I've allowed you to talk. Your mic is on. Please ask your question. Please put your mic on and then ask your question. Okay, I think we've lost Guy Richards. Let's move to Andile. Andile, I'm going to allow you to talk. Oh, your mic is on, Andile. Please ask your question.
Okay, thank you. Can you hear me?
Yes, we can. Thank you.
Okay, the question is for Christian. I just wanted to get a sense from a Minerals Council point of view regarding coal mine bed methane as a source of energy in future, especially considering that the coal mines are likely to be closed in future. Has any investigation been done around that, and in terms of its viability and ensuring productive use, of coal mines in future?
Thank you. Christian, do you want to take that?
Thank you. A very technical question. So there has been a couple of researches done on coal bed methane. It can be done. You've got coal in regions that a lot of people don't know about, like the coal in the Free State, and you also have some coal in the Mogalakwena, just before the Mogalakwena area, which is low-grade coal, and that technology cannot actually be implemented there. There has been some of this that has been tried at Majuba Power Station, where they've tried to do that, but it was on a very small scale and test phase. If you remember, the colliery next to Majuba Power Station had a lot of fractures, and you couldn't actually mine, and so it was eventually closed. But they have done that research in that particular place to just check if it can work. So it's all about implementation, and if somebody has the will to invest in this. Thank you.
And the appetite in maybe quite a risky area. Yeah, okay, look, we're quite well over time, but I'm just going to press on with a couple more questions. And I see Clyde Melanson. Please ask your question and switch on your mic.
Oh, hi, Chris. I don't actually have a question. I have an answer for your question if you're interested.
Please.
Okay, so I'm going to home in just to make it very specific to Dedisa, which is just outside Kruger, Nelson Mandela Bay. It's a 350 megawatt dual open cycle gas turbine running on diesel. There's plenty of space there to build around about 600 megawatts of solar and about 400 megawatts of wind, together with a 350 megawatt 2-hour battery. So you would basically have a suite, if you like, where you could always guarantee 350 because the Dedisa can deliver 350. But the combinations I've indicated would be able to deliver 350 pretty much 24/7. And interestingly enough, that's more or less what Nelson Mandela Bay uses for its power consumption. So that quartet, if you like, of wind, solar, existing gas and battery at that site could basically take Nelson Mandela Bay off grid, so to speak. So I just thought that would be quite interesting. And it also the evacuation capacity that's afforded to that Dedisa is heavily underutilized because it's not running, but it's kind of there. And so it seems insane that we shouldn't do that in an area where there's good solar irradiation, plenty of wind, and that's what I'd like to just propose as a quartet rather than just the OCGT operating with a battery. It works beautifully. I've done all the economics on it. It just needs to be done. But certain people have got gas in their nostrils. Thank you.
Thank you for that, Clyde. You're always provocative, but a very interesting contribution there. And I hope some of the developers start thinking about it and maybe taking Nelson Mandela off the grid. I'd use that lightheartedly, but yeah, a very interesting proposition that you make. I'm going to move to Guy Richards now. I think you're available now, Guy. Please switch on please ask your question.
And thank you very much for taking my question. So my question is really around, so it's around scale. So there's a global trend for mines to become pumped hydro facilities to post mining. For instance, there's a project in India called Pinnapuram, so which consists of a 1.6 gigawatt pumped hydro coupled with 4 gigawatts of solar, and then so 1.6 gigawatts of wind. So the question I've got for all the panelists is that if a mine goes ahead with a small solar and a small chemical battery, so if you compare it to the 1.6 gigawatts that they're doing in India. So if the mine were to go with a smaller smaller scale, the question is, how would it compete against a really large facility?
Okay, so let's put this to, I think, what about let's put this to, where is Muzi? Is Muzi there? Muzi, what do you mining guys say to this idea? Are you there, Muzi?
Yes,
Okay.
no,
I
am. It is an interesting one. I think there are definitely a series of studies that not just maybe in India, but that we've also thought about locally with the water that we do have. I think there are some technical challenges in that you might have to consider concurrent use of the shaft. So if you are actually mining and you have to share that infrastructure, it becomes a bit tricky. And if you are looking in a post-mine closure world, it is quite expensive to maintain shaft infrastructure. So the costs are enormous. You still need to ventilate because people do need to be able to go underground and attend to the pump stations, the equipment that is there. But I do think that certainly, depending on conditions, some projects could be viable, but those have typically been some of the constraints.
Thank you. I'm going to take this as the last question. Gareth, I'm unfortunately going to have to, cut you from this question, and take the last question from Maduna. Maduna, you were on the line, but I don't see you anymore. Is your hand still up, Maduna? If your hand is not up, there's Maduna. I want to take Maduna because Maduna is an old colleague, from the IPP office. I think he was the COO of the IPP office. And I would love to hear from you again, Maduna. So I'm allowing you to talk, so please ask your question. If you can switch on your mic, yeah, thanks.
It's good to see you again. Yeah. Thank you so much for the interesting discussions. I think maybe starting with your earlier question about deploying storage next to the peaking plants. I think if there's sufficient energy coming from wind and solar closer to that substation, probably you can do that. It makes sense because you can store that. If there's curtailment during certain times next to that substation, you can deploy the battery because you can save a lot of money. Instead of curtailing those power plants or those wind and solar, you put it into the storage and you release it later instead of using the peaking plant to generate during peak time. So that works very well. So it's a matter of assessing of how much energy is available in those networks and from where, because if it comes from renewables, then it makes sense. Then the second one that I thought I should just check, I mean, the question about gas and battery storage, it's always been in everybody's mind, and there's a lot of views around that. But I'm not certain in terms of how much batteries can you really deploy on the grid and still make commercial sense? Because at some point, you got to understand the capabilities. I mean, Jason made a point about grid forming and all of that, which is critical. I mean, if you got a lot of renewables and all, you need your network to respond in a particular way. But now, how far would you go with the batteries without necessarily having to bring in gas because of all the things that are associated with gas? I mean, some people, they're arguing that, there's a limit in how much batteries you could put in. At some point, you may have to bring in another technology such as gas that will provide you that flexibility. You might not run it all the time. I know the debate around how much you should run, the load factor for gas and all of that, but I'm not going to get into that. But you could run it, whenever is needed if, your batteries and everything cannot provide you with the energy that you need for a number of reasons. I mean, we know why. So I just want to check how far would you go with the batteries before you think, I think I've got enough batteries on my system. Now I need to bring another technology. Thanks.
Yeah, I think we're going to put this to Jason and just a comment from me. I just wish we had some gas. We talk gas, but we don't have any. Where what we do have is going down, and it doesn't seem like we are getting a viable source of gas in the short. I'm talking about in the next 5 years. But Jason, please answer that question if you can. Your thoughts would be appreciated.
Yeah, thanks, Chris. I completely agree with you. I think you need a balanced mix. What we're seeing in international markets like Germany and the UK is they're implementing a model where they essentially will incentivize procurement of different stability services. So, for example, they'll set a kilowatt hour rate, for example, for synthetic inertia or fast frequency reserve, and that drives private sector investment into very large BESS assets in the grid. For example, we've done recently a project in Scotland in Black Hillock, which is the largest grid-connected battery in Europe, which I would recommend going to see. And that's providing a lot of stability services to the grid there. And I think batteries can go a long way in terms of addressing the stability of the grid as we phase out our coal plants. But you've really got to get the commercials right. So it's not a case of Eskom coming in and being a sort of backer of these projects, in my view. I think that Eskom should lay the foundation for the private sector to invest in these projects. And it really comes from understanding how you want to incentivize your market participants to be able to provide stability services and batteries to the grid. And I think that'll drive a lot of development in that regard.
Thanks, Jason. Look, we're going to have to bring it into an hour. We're kind of nearly half an hour over time. So the audience has been very, very patient with us, and my apologies for going over time. But it's been such an interesting discussion. I just couldn't bring it to an end earlier. And I just want to take this opportunity to thank our participants, our speakers, our presenters who've given of their time so freely, and also for the very valued support of companies like SMA Altenso, Solar Group, Cresco, Sibanye-Stillwater, the Minerals Council of South Africa, and the Power Futures Lab of the Graduate School of Business at UCT. Your support in this webinar is highly appreciated. I think the audience has appreciated. I certainly have appreciated it. I've learned a lot. The mining industry is a critical industry for South Africa. It's in a state of flux and change as we move from old minerals to new minerals, from what may be considered to be dirty minerals to hopefully green minerals of the green future. So it's an interesting environment, mining, a critical environment, and it's been so interesting to hear the different aspects that are the subject of this webinar. So with that, I'm going to say thank you. Keep your eyes open for our next webinar, which will be coming up shortly. You'll see it announced. And also, we want to keep our eyes open for this amazing announcement that is coming from Solar Group and Jonathan. You got us on the edge of our chair, Jonathan. But I guess you want to reserve the announcement for the mining in Indaba next week. That you're carefully timing this announcement for maximum effect. But you've got us all, as I say, sitting on the edge of our chair, wondering what this big announcement is all about. But whatever it is, congratulations and all the best. And thank you, everybody, for attending, and goodbye from me.